Okay, guys, we're going to try to do notes virtually today because I just was feeling pretty bad yesterday as the day went on. So I just stayed home as a precaution and also to cuddle with my little sick little boy. So we're going to try our best to do notes. Before we do that, I want to go over number 29 in homework. Okay, so we had the integral of tangent 4x plus 2. Now, I know the derivative of tangent, but I don't know the antiderivative. So what I'm going to do is I'm going to rewrite it as sine 4x plus 2 over cosine of 4x plus 2. Just using my trig identity there. Then you can play around, but you'll find that the u that works is to pick that bottom, cosine of 4x plus 2. Now, when I do that derivative, that's a chain rule. So you end up with 4 from the derivative of the inside. Cosine will be negative sine 4x plus 2. And I went ahead and skipped the chain rule work. Of course, you would show that. I'm just kind of saving time. So now I divide negative 1 over 4 sine of 4x plus 2 du equals dx. So my integral is actually the integral of sine of 4x plus 2 over u times negative 1 over 4 sine of 4x plus 2 du. Sorry, my pen acts a little weird, especially as I get down further on the page. Signs reduce. That's with the integral of negative 1/4. And I'm going to write it separate because more people can see it that way. That's a du. My antiderivative is negative 1/4 natural log absolute value of u plus c. Sorry, my pen is not doing anything curvy apparently. Get negative 1/4 natural log of absolute value of cosine 4x plus 2 plus c. That's what that says, cosine of 4x plus. That's a plus c. Oh my goodness, pen, come on. So that was 29 in homework. I just wanted to go over that really quickly. Today we're not doing anything new, but I'm going to show you kind of the tricky ones. So here are the tricks of the trade, the ones that would probably stump us the first time we see them. But again, I'm showing you now so that you won't get stumped the next time you see them. So we're going to jump in with a very familiar looking one, cotangent of 7x. So just like tangent, I'm going to go ahead and rewrite that. I'm going to use purple here. A little thinner pen, maybe that'll work. I don't know why everything's so delayed. I'm trying to work on my pen here real quick. So I'm going to rewrite that as cosine. Okay. I'm going to connect this to my computer, so hold on one second. I'm hoping maybe that'll fix it. Try that. So we have, better. Cosine of 7x over sine 7x dx. Just like the last problem, and I don't know what this is doing here. Ignore that. Oh, there it goes. Okay. I'm going to let that denominator be my u. So u is sine x. Du, be careful. It's not just cosine of 7x. Chain rule says the derivative of the inside is 7 times dx. That's where I see a lot of mistakes, is not using the chain rule. So let's divide. I have 1 over 7 cosine 7x du equals dx. Okay. Actually, let me make my pen a little thinner. I think that works a little better. Okay. So now I have the integral cosine 7x over u 7 cosine 7x du. I'm going to kind of leave that one. So actually, it's easier to pull it out too. It's easier to see when you pull out that constant. Remember, that's a property of integrals. So my antiderivative is natural log. So I have 1/7 natural log absolute value of u plus c. And then finally plug u back in. So I have natural log of absolute value of sine x, sine 7x plus c. There we go. So now you've seen this tangent and cotangent. You should not be fooled by them a second time. So study them, know them, They're much easier. Okay, this one's tough. Okay, this you might be thinking of a similar one we did in day one, like this one. Here's day one's problem. I'm like, okay, it looks very similar. Remember, we just picked a tangent in order to, as my u, in order to do that one. Problem is here, if I just pick a sine, I have 3 cosines that's going to have to reduce out. And taking the derivative of sine is not going to work. Even if I take the derivative of sine cubed, that's only going to give me 2 of them. So, not going to work. So what I'm going to do is I'm going to use some identities. Remember cosine squared x. Oh, pen, you were just working fine. Grr. Okay. Telling you what, even when I'm not there, my computer tries to act up. Cosine squared x plus sine squared x equals 1. Well, what the heck? That's sine squared, believe it or not. Okay. I'm going to use that identity. So what I'm going to do is I'm going to pick one of them. I'm going to get rid of my cosines. And I'm going to get rid of all but one. So I'm going to break this up. Okay, let me try to disconnect or connect. Oh, see, works. Sine cubed x, and I'm going to break that up into cosine squared x, cosine x. Just comes from playing around with this a few times. Let me pause real quick. I've got the doctor calling. Okay, sorry, I had to answer the doctor calling. Okay, so now I'm going to use this identity to make sure I only have one cosine. So I end up with sine cubed x. I'm going to replace that with 1 minus sine squared x, cosine x. So now it actually becomes like the problem we did the other day, because a derivative of tangent is right here. This is just one of its derivatives. Same now, I have the derivative of sine is just a cosine. So I'm going to let u be just a sine. Then du is cosine x dx. Okay. Divide, I get 1 over cosine x du equals dx. Okay, so I have the integral right here. So I have u cubed 1 minus u squared cosine x 1 over cosine x du. Cosines reduce. So I'm going to go ahead and distribute that. That's u cubed minus u to the 5th du. Power rule says I have 1/4. Oh, pen. Sorry, it's doing it again. U to the 4th minus 1/6 u to the 6th. That's a 6. Oh my goodness. Sorry, guys. I don't know why it's just acting up like this. Won't let me do anything curvy without going super slow. Plus c. Okay, plug back in. 1/4 sine, well, I don't need parentheses there. I'm going to go ahead and write it as sine to the 4th. Maybe I can write it as sine to the 4th x minus 1/6 sine to the 6th x. Oh my goodness. Sine to the 6th x plus c. There we go. There will be some in your homework tonight where you're going to have to try to use some trig. You're trying to get it to work. Very similar. Now, I know the antiderivative of secant squared, okay, but I don't know secant to the 4th. So I'm actually going to break it up as secant squared, secant squared. Now, don't tell me that's tangent, tangent. Don't do that. We have no property for multiplication, remember? But I do know some identities. I know that a secant squared is tangent squared plus 1. And I see the derivative of tangent is already there, so I'm going to let u be tangent. Du is secant squared. dx divide 1 over secant squared x du dx. So I have the integral u squared plus 1 times secant squared x 1 over secant squared x du. Reduce those secants. So I have the integral of u squared plus 1 du. I'm telling you what, this pen, it's like it gets to the end of a problem, it's just like, nope, not working anymore. Antiderivative, 1/3 u cubed, that's what that says, believe it or not, plus u, right? The antiderivative of 1 is u because we are in u, plus c. Oh, goodness, goodness, goodness. So plug u back in, 1/3 tangent. I'm trying to write slow, but it's okay. Let me flip my computer again. Oh, turn it off. Perfect, like a charm. Tangent cubed x plus tangent x plus c. But the biggest thing I see people do is they say the antiderivative of 1 is x, but we're in u. Our variable of integration is u, so make sure you use the correct variable. There we go. So there's a few identity ones. Okay. Oh, star this one. This is one we definitely need to know. Okay, I remember this one specifically because I remember, ironically, I had the stomach flu in sophomore year of college. And it was exam week, and I had 3 exams that day. And if you don't know, in college, you better show up to your exams. Unless you're dying in the hospital, you show up to your exams. So I barely could get dressed. My roommate drove me to class from the dorm, so I couldn't even walk. It was awful. I threw up in between exams several times. It was just terrible, terrible day. But I ended up with 2 A's and a B+. I'm still bitter about that B+, because it was in my Diffie-Q class, and this was the problem that I could not remember for the life of me. And I'm going to blame it on the flu. But I probably should have studied a little more. Now, I see, I'm going to pull the dx off to the side. Oh, really, pen? Oh, it's going to be long. X squared dx. If I had a constant on top other than 1, I would pull it out of the integral. But I don't. Because now come look at it. I have a constant over constant plus a square. That should remind you of an arctangent, right? Constant, constant, square. But on an arctangent, it's 1 over 1 plus x squared. So that's what we're going to work towards. This needs to be 1, and this needs to be 1. Well, the top is already good. If not, I would just pull out a constant. The same thing here. I'm going to pull out 64. But when you pull it out of the integral, it's still in the denominator. So you have 1 over 64. But here's the thing. You pull it out of here, it's addition. You have to pull it out of here too. So that becomes 1 plus 9x squared over 64. You have to kind of like factor it out of both terms. Now I'm going to rewrite that as a perfect square. This happens to be, oh, pen. Three x over 8 quantity squared. It's an 8. Oh, this is getting annoying. I'm sure it's annoying to you. It's really annoying to me. See if I can disconnect and make it. Yeah, I'm going to do my substitution. Let u be that inside of 3x over 8. Du would be 3/8 dx. So I have 8/3 du equals dx. So I'm going to go up here. I have 1/64 integral 1 plus u squared times 8/3 du. I'm going to go ahead and multiply my 1/64 times 8/3. The 8 and the 64 reduce. I end up getting 1/24. My antiderivative is arctangent of u plus c. Plug u back in. Then plus c. There we go. You do need to know how to manipulate that into an arctangent. Likewise, we'll do one on practice that's an arcsine. You've got to recognize those inverses, which is why I said it's so important to know your trig derivatives. If you don't know your derivatives, the antiderivatives are going to be darn near impossible. Okay, so make sure you have those memorized. Okay, this one really fools people. And it's because it's something you don't want to do, but you're going to have to. You cannot split this up. I know some of you be tempted to try to split up, but that's only if there was one term in the denominator you could divide the numerator, but you cannot go backwards in that case. And this is not any kind of derivative that we know. It's not an arctangent, not an arcsine, not an arcsecant, none of those. So we'd have to kind of, search the cobwebs off our brains, try to figure out other methods. Conjugate doesn't work. Nothing works except good old long division. So I'm going to divide this up and do 6x divided by 3x plus 5. I'm going to put plus 0 here. So what does 3x need to be 6x? Well, just a 2. Remember, you multiply, so I have 6x plus 10. Subtract 0. 0 minus 10 is negative 10. So I have plus negative 10 over the divisor. Oops, 3x plus 5. That's a 3. So when I rewrite that, I ended up getting 2 minus 10 over 3x plus 5 dx. Okay, here's another spot this is so tough. This term needs substitution because of that 3x plus 5. Okay. This term does not. Okay. So if one part needs substitution, one does not, we have to break that up. So I have the integral of 2 dx minus, and I'm going to go ahead and pull out the 10. Okay, so let's do substitution over here. So I have u is 3x plus 5. Du is 3dx. I have 1/3 du equals dx. So here, the antiderivative is 2x minus 10 times the integral 1 over u times 1/3 du. So really that's 10/3. So I have 2x minus 10/3 natural log absolute value of u plus c, and finally plug u back in. Again, I know many of you would not see this problem and think, oh, I need to do long division. But I'm showing you all the tricky ones so that when you do come across them, you might think, hey, would long division work? And then try it and see how it goes. So these are all the tricky ones that get people. Speaking of that, star this one. AP Test loves these. I'm not sure why. They put them especially on the BC exam, but I've seen them before in the AB many times. They love these problems because let's start this problem like we normally would. Most of you would pick x minus 4. Du is 1 dx. So I'd have the integral x square root of u times du, which is a problem, right? All of the x's should reduce out. We should never have two variables in there. But there's really nothing else to pick for u, okay? Nothing else works. If I try x, it does the same thing. So what I'm going to do is kind of cheat right here. I have an x left, so let's solve for x. If I do that, x equals 4 plus u. Right? If I just add 4 to the other side. So I really have the integral of 4 plus u square root of u du. So I kind of did a double substitution of u there. Okay, it's kind of cheating a little bit. I'm going to go ahead and distribute that. That is 4u to the 1/2 plus u to the 3/2, right? U to the 1 times 1/2. Antiderivative, so I'm going to add 1 to the power, get 3/2. Let's see, divide, 8/3. Let me check, yep, 4/3. Plus, add 1, I get 5/2. Divide, I get 2/5. Plus c. So I get 8/3 x minus 4 to the 3/2 plus 2/5 x minus 4 to the 5/2 plus c. There we go. So a double substitution one is one you kind of need to know. And a hint to use if they're the same power. Not always. We'll do one here in a second where it's not. But that's kind of a hint. But it's, again, just when you try it and you get stuck, you start thinking of what else could I do to get unstuck kind of thing. So let's do another one. This one you may not see right off the bat. A lot of people will be tempted to use u as 4x cubed. Okay, you can try. It does not work. So I'm going to let the inside again. So x squared plus 1. So du is 2x dx. Divide. 1 over 2x du is dx. So I have the integral of 4x cubed square root of u 1 over 2x du. Okay, we have a little bit of reducing. The 4 and the 2 reduce to 2. One of the x's reduced. I have 2x squared square root of u du, which is still a problem because I still have x's and u's, and I need to be in terms of only u. So I'm going to go back here, and I'm going to solve for x squared. X squared is u minus 1. So I'm going to plug that in. So I have 2 u minus 1 square root of u du. Let's distribute. So I have 2, let's see, u to the 3/2, right? 1 and 1/2 minus 2 u to the 1/2. I distributed my 2 and my square root of u. Antiderivative. So let's see, add 1 to the power. Divide. Get 4/5. Minus, add 1 to the power. Divide. Let's see, 4/3. Plus c. Finally, plug u back in. So I have 4/5 x squared plus 1 to the 5/2 minus 4/3 x squared plus 1 to the 3/2 plus c. There we go. They are definitely tricky the first time you do them, but then again, when you get stuck on a problem, ask yourself, can you do a double substitution? I most often see them with square roots, but they have occurred in other problems with parentheses or something like that. But so here's a u-try. So I want you to go ahead and pause the video, please. Pause the video. I want everyone to work the problem. And then after a few minutes, when it looks like everybody's done, go ahead and hit play. Okay. Hopefully everyone had a chance to work it. So I'm going to go ahead, and first thing I'm going to do is I'm going to pull out that 20. That way it created a 1. I'm going to move that dx off to the side. I don't like it there. Now, I recognize a square, constant, so I'm going to try to make this be a 1. So I'm going to factor out a 1/16. So when I do that, I have 20/16. 1 over, now 16 over 16 is 1. I'm going to go ahead and write that as a squared. Now, I see a lot of people put 2x over 4 squared. Please don't do that. That reduces. It makes your life a whole lot easier. Because right now, it's really x squared over 4, which is x over 2. Okay, so then I'm going to let u be x over 2. du is 1/2 dx. 2 du equals dx. So I'm going to go ahead and reduce this 20 over 16. So divide by 4, I get 5/4. integral 1 over u squared plus 1 times 2 du. Multiply my 5/4 and my 2, so you'll give me 5/2. Arctangent of u plus c. Plug your u back in, so I have 5/2 tangent inverse of x over 2 plus c. There we go. So tonight in homework, you have some normal ones and you have some tricky ones. So I wish there were more tricky ones. They were most are pretty normal, but we're going to keep doing this. We're going to have some practice with some of the trickier ones on there too. Okay. Homework tonight is day 2. I know notes were pretty long today, but you still should have a good roughly 20 minutes or 15 minutes left. Okay, so go ahead and work on math homework. So 21 and 30 through 40, check the odds. Check the odds. So go ahead and get started on homework. I will hopefully be back tomorrow. Not quite sure. I'll let you know if anything